let's take a look at our lesson for today. We're going to be working on solving problems with parametrics. Okay, that sounds like fun. All right, so our first example, we have these parametric equations listed right here, or actually it's one parametric equation. Recall that the parametric equation has an x equal portion and a y equal portion, both with respect to t. So that parametric equation creates this curve right here, creates this graph. All right, so let's see what they are talking about. So they say the curve crosses the y-axis at point A. So we see that going on right here. And crosses the x-axis at point B. Okay, we got that. So the first part says show that A has coordinate 0, 0, 0, 3. So those words show that, that is kind of that's a mathy thing, right? That basically means show me how you know that mathematically. Don't just say, oh, because it is. I mean, you've got to show the steps. How do you know that the coordinates are 0, 3? So let's think about what the characteristics of that point are. The point there at basically crossing the y-axis. We know that all the points on the y-axis have an x coordinate of 0. Okay, well, let's start with that concept. So we are going to write, we're just communicating our thinking. If x equals 0, this is just a communication strategy. Okay, if x equals 0, then I'm going to substitute a 0 in for x. And I will be able to find the t value, and we could think of it as time. I would be able to find the t value where that's true. Okay, so let's start with that concept. Let's find the t value where that's true. So I would move the 1/2 t over. Then we're going to multiply by 2 on both sides. We're solving for t. And I get t is 2. Okay. So if I know t is 2, how is that going to help me? Well, if I take this time and substitute it back, into the parametric equation, it should give me the point where that occurs. So we already know when x is 0, t is 2. So A, okay, we've already know that x is 0 when t is 2, because that's how we found t, right? We set x equal to 0 and we located t. So now let's figure out what the y coordinate is. Okay, so we know the t value, so let's use our y equation and let's substitute the t value, the t is 2, into the y equation, and let's work that through. So we get 4 minus 1, or 3. And so what we've just done is we have shown that, we have accomplished what they've asked, we've shown that A has the coordinate 0, 3. Okay, how are we doing? Okay. The second part is asking us to find the x coordinate of point B. Well, okay, let's think through that. So point B is on the x-axis. What do we know about all points that lie on the x-axis? Yep, that's right. Their y value is 0. So we're going to go along with our communication. If y equals 0, and so then let's plug in 0 into this second piece right here, the y equals equation. 0 equals 2 to the t minus 1. Okay, let's see, what does that do? So I move the 1 over, so 1 equals 2 to the t. Okay, perhaps you remember from Algebra 2 how to solve equations like this, perhaps, exponential equations. In this particular case, we have t to some power is 1. Excuse me, 2 to some power t is 1. Well, 2 to the 1 is 2. 2 squared is 4. That's not 1. So we have to think about what do we know about exponential equations. We know that something raised to the 0 power is 1. So that we certainly know that. So basically that tells us that our t value is 0, because 2 to the 0 is 1. All right. So let's go from there. So, okay, t value is 0. All right, so let's plug that into our x equal equation. X equals 1 minus 1/2 times 0. So x is going to be 1. So our point B is going to be, and actually they just wanted the x coordinate of point B, so that's fine. We can give that to them. We don't need to give the whole point. So the x coordinate is 1. And you might be thinking, oh my goodness, I don't remember how to solve exponentials. How did she know that that t was 0? I'll give you a short little reminder. So what we would like is we would like the bases to be the same. That's what we would like. So there's a couple different ways to do this. I can write 1 as 2 to the 0 equals 2 to the t. Remember, when the bases are the same, we can drop them and we can say 0 equals t. That's one way to do it. This is just a little reminder, like a, I don't know, reminder. Another way to do it is to take the log of both sides, which you're probably like, oh no, we don't want to go that route. Okay, I get it. I know why you might not want to go that route. So if we take the log of both sides, log of 1 equals log 2 of t, and then we pull the t down, t log of 2 equals log of 1. So we divide by log of 2, which we don't even care what that is because it's just some random number. It's a decimal number, but we know log 1 is 0, so t is 0. And you're like, yeah, let's not do that. The chances of us doing this with the logarithms, we're not going to be really working with the logarithms. We should be able to solve it like this, where we can make the bases the same. But that's just a little reminder, yay, like a flash from the past. How would we do that? Well, that's how we would do it, or how we did do it last year. Okay, so let's take a look at our second example. They're giving us a parametric equation, x equals t minus 1 and y equals 4 minus t squared. And it tells us that the curve meets the x-axis at the points A and B. Ooh, 2 different points. Now that's interesting. So what do we know about the x-axis? We know that the x-axis, every y coordinate on the x-axis is 0. So that means y would be 0. That's all along the x-axis. So that's a clue that we get from this, thought that it's at the x-axis. So let's go ahead and take the y, this one, and sub in 0 for the y. So 0 equals 4 minus t squared. And then this one's a fairly simple one. We can actually move the t squared over, square root both sides, and we get t is plus or minus 2. Or we could have factored it. That would have been fun also. So what we need to do is we need to focus on both those t values. T equals -2 and 2. All right, so let's work first with t is -2. Okay, so let's look at this scenario. So what am I going to have to do? Well, I'm going to have to substitute in a -2 in both of my equations, my x and my y equations, so I can get the coordinate of the point. All right, and we're going to call this point A, just because it's the first one. -2 comes before 2, so we'll just call this point A. A is going to be the point where t is -2. Okay, so we would say x equals -2 minus 1. So my x value for this particular point is -3. Y equals 4 minus -2 squared. And that gives me a 0. So point A is actually at -3, 0. Okay, how's that? You doing okay? All right, so let's look at point B. Point B, that's where t is +2. Okay, same scenario. We're going to have to substitute them into the parametric equation. So x equals 2 minus 1, or 1, and y equals 4 minus 2 squared, or 0. And so point B is actually 1, 0. All right, and these are examples. These two problems are examples of working with parametric equations, problem solving, that don't require a calculator. On the next page, we are actually going to need a calculator on the next page. So hopefully you have yours handy and you can get that out and we can work through this. So this is particle motion, and we have two equations. You will not have to memorize these equations. They will be given to you. They're up here in this purple highlighted, or the pink highlighted box with purple around it. So they're parametrics, right? We have an x equal and a y equal. V naught, V with the little y, 0 down there is called V naught. That is initial velocity. Theta is the angle measure provided. And t, is time. That's our parameter. H is initial height. And the other variable is g, and that is a constant. It's a gravitational constant, a constant of gravity. And we will give you what that constant is. So this is a gravity, like gravity constant, which you may remember from physics. All right, so that's what those stand for. So let's use those and come up with an equation for number 2. So a ball is thrown horizontally at an angle of 45 degrees from the top of a tower at 30 yards per second. So this is our V naught. Okay. This is our H, it's our height. This is our angle measure. And so now we should have everything that we need to write our equation. And the G, I'll give you in just 1 second. Yeah, we're going to go through that in just 1 second. So, all right, so let's write the parametric equation. So we've got x equals, we've got our V naught, which was 30 cosine of 45 degrees t. So that 30 cosine 45 degrees, it's going to make some weird decimal number. And then we have our variable t. Okay, great. So y is going to be, we've got our -1/2. Now, typically, if it was feet, so the little g guy, if it was feet, it would be 32, would be the constant of gravity. Since it's yards, so this is feet. If it's yards, it's like, that's feet, so we're going to have to divide that by 3. That would be yards. So it's -1/2 times, since we're in yards, 32 thirds. And again, you'll be given the constant of gravity. 32 thirds. And then we've got t squared plus our V naught is 30. And then we've got sine of 45 degrees t. and our initial height is 45 yards. Now luckily they've given us everything in yards, so we don't have to do any crazy conversions, so that's good, yay. All right, so we're going to need our calculator. I'm going to put those in my calculator in just a moment. I am not going to put them in parametric mode because we can't really do a whole lot of, maxes and mins and all that kind of business in parametric mode. I'm going to put them each in as a function. And I want to make note, this one is for horizontal distance. And this one is for vertical distance, which should make sense to you since X is the horizontal one and Y is the vertical one. That should kind of make sense that that's what they would be used for. And that's what we're going to use them for. So when we want to find the maximum, let's go through and just kind of highlight some things we're going to work with. If we want maximum height, we're going to need to use the Y equation, right? Because that's height, vertical height. If we want to find the horizontal distance, we're going to use the X equals equation. So that's the Y equal equation, that's the X equal equation. Horizontal distance. Okay, great. So we're getting, an idea of what we're doing. So let's just stop there and let's work on part B. So we want maximum height and horizontal distance when it reaches the maximum height. So I'm going to pull up my calculator and we're going to do graphing. And I'm going to stay in function mode. And I'm simply going to put in my X equal equation first. So I'm pretending that this is X. I know it's not an X, but I'm pretending. And this is going to be 30 times cosine of 45 degrees, and I'm in radians, so let's change that to degrees. Oh, that's nice. It just deleted it for me. Wasn't that nice? Okay, we can do it again. Sure. So 30 times, okay, so we want, what do we want? Cosine of 45 degrees. And we want that, and since we're in function mode, we're not going to use a t, we're going to use an x, because that's how function mode works. So F1 is my X equal equation. So there's my X equal equation, and it even just shows it right there. That's my X equal equation, F1. So let's hit the tab, and let's put in our Y equal equation in F2. So Y equals, and so let's do a fraction. So we've got negative 32/6, because 2 times 3 is 6. Then we have a t squared, so I'm going to do x squared, because again, we're in function mode, plus, then we have 30 times sine of 45 degrees, so sine of 45 degrees, and that's times t, which again, function mode, we're going to use an x. And then we've got our height of plus 45 yards. And that's our Y equal equation. Okay, great. I can't quite see the top of it, so I'm going to go in and I'm going to change my window. So menu, window. I like to adjust it myself. So I'm going to, I think I want to change my Y max to say, oh, I don't know, 140. Let's just change to 140 and see. Okay, I can see pretty good. I can see what's going on. All right, great. So we have this all put in. Let's go back and look and see what they want us to do. We want the maximum height, so that's where you need to get the Y equal equation. Let's put a little, this one was F sub 1, and I'm just going to make a note to ourselves. That one's F sub 2, just so that we know which one was which. Okay, so I need to take the F sub 2 equation. I need to find the maximum. That's going to give me the maximum t value. So what do I do when I get the maximum t value? Okay, then I want to find the horizontal distance. If I know the time when the ball was at its height, then I can plug the time into my x equal equation and find the horizontal distance. So that's our game plan. That's what we're going to do. All right, so let's go back to our calculator and let's find our maximum. We want to be looking at this one. I'm actually, just because I want to make it easy on myself, I'm going to go back up here and I'm going to, at this time, I'm not going to graph the x one. I just want to make my work simple and clean. It's still there, it's logged in there. I just don't want to show on the graph because I'm focusing on this maximum value is what I'm focusing on. So let's do menu, analyze graph. We want our maximum. Okay, so we go to the left, that's our lower bound. We go to the right, that's our upper bound. And this is the t-value. Okay, this is the t-value. I want to use that in like several instances. So I'm going to click on it and I'm going to store it. I'm going to store this value. And so see right at the top, this blue S2 STO, I'm going to hit Control VAR, so that's storing it. And I'm going to call this A. I'm going to call it, you can call it whatever you want to, but I'm going to call it A. So now I can see this is highlighted and I've stored it as A. So whenever I put in an A, it's going to give me that number. Okay, you ask, why are you doing that? Well, I'm going to need that number in just a moment. So this is when we want to find the maximum height that it traveled. So this stands for height, right? This is the time, this is the height. So this is the maximum height that it traveled, 66.094. All right, so let's go back to our document. Okay, so the maximum height. All right, so we have max happened at t equals, and we just need to write this down so we're communicating what we're doing, 1.9887. And I'm just going to make myself a little note. I stored this number, stored it as A, just in case I have forgotten. You know, who knows what can happen? Maybe I'll forget. I stored it as A. So we saw from our graph the max height was 66.094 yards. Now recall, unless we are told otherwise, our default is thousandths. Okay, our default is thousandths. So great, we got the maximum height, we know when it happened. Now we want the horizontal distance. So what we actually would be doing, and I'll just write it out, to find the horizontal distance, we're going to put in that 1.9887, etc., into our x equal equation. So I would have 30 cosine 45 degrees, that's a number, and I'm going to multiply that by, you know, the 1.98, so forth. Now I'm going to, of course, have my calculator do that. And this is going to be horizontal distance. All right, so how do I do that? How do I make my calculator do this? Well, there's a very easy way, which is, of course, the way I'm going to show you. What we need to do is we need to get another document. So let's add a page, Control Doc, add a page. We need a calculating page. Okay, we need a calculating page. And what I'm going to do is, if you recall, my variable, the one I stored, f1, was the x. I want f1 of, well, first of all, before we go through this business, I just want to show you that if I hit A and hit enter, that number is stored there that we stored. You know, the one we found in our grapher, that's stored there. I just wanted to be clear, that's there. So I'm going to take that number, I'm going to put it in my x equal equation. So how do I do that again? So I go VAR, that's where my variables are stored. That's the x equal equation, and I'm going to put in the A, because, you know, that's where we stored it, and I'm going to hit Control Enter, and this is the horizontal distance that it went. See, isn't that easy? Or if you don't like that, if that really troubles you, you could just I'll go back to the document. You could just put all this in your calculator like that, and I promise you're going to get the exact same answer. That's just a faster way to do it. So it's 42.188 yards. Okay, so there's our max height, and there's our horizontal distance. All right, how are we doing? Okay, so last part of this particular problem, it says, when did the ball hit the ground? When did the ball hit the ground? Let's think about what that means. Let's look at the graph again. Let's see if we can figure out what in the world. Let's go back to our grapher. So this is like, so we're 45 feet high, we're right here, and the ball goes like this, and then it goes like travels. This is the path, the vertical path the ball is traveling. So as I hit here, wouldn't this be the ground when y is 0? Yeah, this would be when y is 0. So what I need to do is figure out when is that happening. So that would be looking for a 0. So we would do our menu, analyze graph, 0. And so we go to the left of the 0 and then to the right of the 0, and there's the 0. Okay. Now I want to use that number. So I'm going to highlight it, and I'm going to store it. So Control var, I'm going to store it. I'm going to store it as B. I'm boring. I just use A and B. You can use whatever number or letter you want to. It's fine. Okay, so this is stored as B. This is when the ball hits the ground. Okay, that's when the ball hits the ground. So let's put some notes on our paper. All right, so when did the ball hit the ground? So it was grounded at t equals 5.509 seconds. And I'm just putting a little note right here. I stored as B, just to remind myself. Okay, so what am I going to do? I'm going to find out, it wants to know horizontally how far did it. So horizontally means I need to use the x equal equation, and I need to put this number in. Okay, we can do that. We can totally do that. So let's go back to our graph. Okay, so let's go to our calculator page, and I need my x equal equation again, which you know is this one. That's my x equal equation. And this time I want to put B in there, right? Because that's the time when the ball hit the ground. And so Control Enter. And now I have how far horizontally, because this is an x equal equation. Remember, x is horizontal. How far horizontally it traveled was this 116.864. So let's go back to our document. So it traveled, so the horizontal distance was 116.864 yards. All right, yay, and that was our very first problem with parametrics and a calculator. How's it going? Okay. We have one more. It's very similar. It's just more practice doing what we were just getting finished doing. So, okay. We have, oh, look at that. They're giving us yards and feet. Oh, that's not very nice, mixing units like that. Okay, that's okay. We can deal with it, right? So from a point 30 yards directly in front of a 10-foot goal post, a football is kicked with an initial velocity. So this is our V naught. And this is our angle. Okay, so let's worry about those later. Let's not worry about that just right now. So I'm gonna draw a picture. Okay, I'm not a great artist, so I apologize right now for the stick figure. So here we go, they're kicking. Here's our goal post right here. and it's not to scale, obviously. This part right here is 10 feet, it says. 10 feet. And this part right here is 30 yards, and I don't really want to use yards, I want to use feet. So we're going to go with 90 feet. Let's get rid of the yards business. All right, so here we go. So using our formula, x equals, our initial velocity is 60 cosine of 30 degrees t. There's my x equal equation, and my y equal equation is -1/2, and it's feet, which is 32 for the gravity, t squared plus 60 sine of 30 degrees t, and it's on the ground, so we don't have a plus h. We don't have a plus h because it's on the ground. So this is our set of parametric equations. Okay, so I'm hoping that we're kind of comfortable with the calculator right now, so I'm not going to go back and just show all the calculator input. Hopefully, if that's okay with you. I'm just going to talk through what you would put in your calculator. So it wants to know if the player will make the field goal when and where does the ball hit the ground. Okay, so what we need, let's write down what we need. We need the time when the horizontal distance equals 90. That's what we need. We need that time because that's when, that's right here. That's when we get to the field goal. It's right there. So we do 90 equals, where it's horizontal, so it's the x equal equation. 90 equals 60 cosine 30 degrees t. And we use our calculator. You could, you could do it just old school and just divide that out and stick that in your calculator. And you'll find that t is 1.732, etc. seconds. And I stored this as c when I was doing my work. I stored it as c. Okay, so that's when we're at 90 degrees now. Okay, so when we're 90 degrees, that's good. I know that, but I need to know if it's going to go over the goalpost. I need to know that. So I need to know the height. What is the height at that time? How high up is it? So I'm going to substitute in for my y equation. I'm going to substitute in the c, which is this 1.732 business, and that gives me 3.9615. Ooh, the goalpost is 10 feet high, so that is not high enough to clear the 10-foot goal. It's not high enough, so they don't make the goal. Now it wants to know when and where does the ball hit the ground. Okay, so we would need to go back to our y equal equation. We would set our y equal equation to 0. Of course, we would do this in our calculator. And y equals 0 at t equals 1.875 seconds. And I stored that as d. Okay, so I have when y is 0, we did one just like that on the one right before. When does it hit the ground? That's when y is 0. That's when it hits the ground. So what's it want to know? When and where? So that's the when. Okay, it hits here. That's the when. Where? Let's include the units. Where? Well, how are we going to know where? Yes, we need the horizontal distance. So we would put this is d, so we would stick that d variable, the d value, 1.875, etc., into our x equal equation. and that gives us 97.428 feet, and that's the horizontal distance. All right. Okay. Hopefully that was helpful. Yay. All right.